Something enormous is happening to the universe right now, and almost no one feels it. The destruction is silent, invisible, and unstoppable. Space itself is stretching, not slowly, not gently, but faster with every passing moment. Between galaxies, between stars, even between atoms, the universe is growing larger. This expansion is not driven by explosions or motion through space. It is space itself expanding, carrying everything with it. Scientists call the force behind this expansion dark energy, and it dominates reality. Roughly 70% of everything that exists is made of this unknown influence. We live inside a universe that is quietly pulling itself apart. Picture the cosmos not as a solid structure filled with stars, but as an ocean of emptiness. Matter exists only as scattered islands drifting farther from one another. Each galaxy is a lonely archipelago surrounded by vast, light, devouring darkness. These islands are not moving toward reunion, they are drifting apart permanently. The universe is not heading toward togetherness. It is heading toward isolation. If you could step outside the Milky Way and observe the universe from afar, you would not see a crowded place. You would see emptiness almost everywhere. Every star, every planet, every human being exists because of matter, yet all the matter combined makes up less than 1% of the universe. Everything else is void. Take every galaxy we can observe, compress every star, planet, and particle into a single region, and you would still barely fill a microscopic fraction of cosmic space. The universe is not mostly full, it is overwhelmingly empty. The average density of the universe is so low that it defies intuition. In a cube of space, 1 meter on each side, there are only a handful of hydrogen atoms drifting through the vacuum. Walk into an empty room on Earth, and the air around you contains billions of times more particles than the same volume in deep space. The emptiness between galaxies is not just empty, it is almost nothing. This emptiness is not chaotic or random. Astronomers have mapped the universe in detail, and what they found is disturbing. Matter is arranged in thin strands and sheets, forming an enormous cosmic web. These filaments connect clusters of galaxies like glowing threads, while between them stretch vast regions where almost nothing exists. These regions are called cosmic voids, and they dominate the universe. The largest structures we know are not galaxy clusters or superclusters. They are these immense voids. Imagine the universe as foam floating on water. The bright edges of the bubbles are where galaxies cluster. The interior of each bubble is nearly empty. We live on one of those thin glowing edges, unaware of the immense darkness surrounding us. Most of the universe consists of these bubbles of nothingness, expanding quietly in all directions. This matters because the emptiness is growing. Every second, new space is created between galaxies. The expansion is not slowing down as scientists once expected, it is speeding up. In 1998, astronomers studying distant supernova explosions discovered something shocking. Instead of slowing due to gravity, the universe's expansion is accelerating. This meant some force stronger than gravity was at work, pushing space apart from the inside. That force is dark energy. We do not know what it is. We cannot see it, measure it directly, or interact with it. We only observe its effect, the universe expanding faster and faster. The more empty a region of space becomes, the more dominant dark energy grows there. Emptiness is not passive, it is active. It pushes outward, overpowering gravity across vast distances. Right now, you exist in a temporary era. Stars still shine, galaxies are still visible, clusters of matter still cling together. But this is a fleeting phase. With every passing moment, more space opens between cosmic structures. Eventually, entire galaxies will drift so far away that their light will never reach us again. They will not fade gradually. They will simply disappear, crossing a boundary beyond which communication is impossible. The void does not wait for the future. It is already here. It surrounds us in every direction, expanding relentlessly, and its true scale is almost impossible to grasp. When astronomers completed massive surveys of the universe, mapping millions of galaxies across billions of light years, they expected to find large clusters as the dominant features. Instead, they found emptiness, enormous bubbles of near vacuum, some stretching more than a billion light years across. Light traveling at the maximum speed allowed by physics would take longer than Earth's entire history just to cross one of these voids. Dinosaurs roamed this planet while photons were already traveling through darkness, and they still have not reached the other side. Inside these voids, galaxies are nearly absent. Where dense regions contain dozens of galaxies within a few million light years, voids may contain only one galaxy in tens of millions of cubic light years. You could fit millions of galaxy clusters inside a single void and still have room left over. These regions are not empty by accident. They are the natural outcome of cosmic evolution. Computer simulations confirm this. Starting from conditions shortly after the Big Bang, gravity pulls matter together into filaments, while empty regions expand between them. This structure emerges naturally, and observations match the simulations remarkably well, but there is a problem. The real universe's voids are growing faster than predicted. Dark energy is not merely maintaining emptiness. It is amplifying it. Measurements show that voids expand faster than gravity alone would allow. Galaxies sitting on the edges of these voids are caught in a cosmic tug-of-war. Gravity tries to keep them bound to nearby structures. Dark energy tries to pull them into isolation. In dense regions, gravity still wins. In the voids, dark energy dominates completely. This process is dividing the universe into isolated islands. Imagine standing at the edge of a widening chasm. At first, you could cross it. Over time, the gap grows wider until crossing becomes impossible. That is what is happening to galaxy clusters across the cosmos. The voids between them are becoming permanent barriers. And one void, in particular, reveals just how extreme this emptiness can become. In the early 1980s, astronomers discovered a region of space that seemed wrong. No matter how deeply they looked, they found almost nothing. This region spans hundreds of millions of light years and contains a tiny fraction of the galaxies it should. Where thousands were expected, only a few dozen exist. It is one of the emptiest known regions in the universe. If our galaxy were located at its center, the night sky would appear almost completely dark. Telescopes would reveal only a handful of distant smudges instead of the vast cosmic panorama we see today. This void challenges our understanding of how the universe evolved. According to standard models, it should not exist in such an extreme form. Yet it does. Some scientists believe this void formed from a region that was slightly less dense in the early universe. As expansion continued, dark energy pushed matter away faster than gravity could reclaim it. Over billions of years, the region inflated into near-nothingness. Other researchers suggest something more unsettling, that dark energy itself may not be uniform. Some regions of space may experience stronger expansion than others. If that is true, then the universe is not evolving evenly. Some areas are being erased faster than others. Entire cosmic neighborhoods may be fading at different rates. The force responsible for this destruction remains mysterious. Dark energy does not clump, it does not dilute. As space expands, dark energy stays constant per unit of space. Create more space, and you create more dark energy. This makes the expansion self-reinforcing. Observations show that galaxies separated by vast distances are moving apart at incredible speeds. At sufficiently large scales, this separation exceeds the speed of light, not because galaxies are traveling through space too fast, but because space itself is expanding between them. Beyond a certain distance, light emitted today will never reach us. This boundary is known as the cosmic event horizon. Galaxies that cross this horizon vanish forever from our observable universe. No signal, no message, no light can ever reach us from beyond that boundary. Entire civilizations could exist there, shining brilliantly, and we would never know. That boundary is moving inward. The observable universe is shrinking. We are living during a brief cosmic moment when the universe is still visible, still connected, still filled with light. This moment will not last. The void is spreading, the darkness is winning, and what this means for life, intelligence, and the future of everything is far more disturbing than empty space itself. The force driving the universe apart was not discovered because scientists were looking for it. It revealed itself because something went terribly wrong with expectations. For most of the 20th century, astronomers assumed the expansion of the universe must be slowing down. Gravity pulls matter together. Over time, it should act like cosmic brakes, gradually reducing the outward motion left over from the Big Bang. That assumption felt inevitable. It was wrong. When astronomers began using distant stellar explosions to measure cosmic expansion, they expected to confirm this slowing. Instead, the data pointed in the opposite direction. The farther away a galaxy was, the faster it was receding. More unsettling still, galaxies at the same distance appeared to be moving away faster now than they were in the past. Expansion was accelerating. This discovery shattered cosmology. Something invisible was overpowering gravity on the largest scales imaginable. Scientists gave it a name not because they understood it, but because they didn't. Dark energy became the label for the unknown force stretching space itself. To understand why this is so disturbing, imagine drawing dots on the surface of a balloon. As you inflate the balloon, every dot moves away from every other dot. None of the dots are moving on the surface. The surface itself is expanding. Now imagine the balloon inflating faster and faster with time. That acceleration has no obvious cause, yet that is what our universe is doing. Dark energy behaves like a property of space itself. It does not clump into objects. It does not weaken as space expands. In fact, the opposite is true. As space grows, the total amount of dark energy increases. This creates a feedback loop. Expansion creates more space. More space means more dark energy. More dark energy causes faster expansion. In the early universe, this force was insignificant. Matter was packed tightly together, gravity dominated, galaxies formed, stars ignited, but as the universe expanded and matter spread thinner, gravity weakened across large distances. Dark energy did not. Eventually, it took control. Measurements from multiple independent sources confirm this picture. Observations of distant supernova, the cosmic microwave background, galaxy clustering, and gravitational lensing all point to the same conclusion. Roughly 70% of the universe's energy budget is dark energy. About 25% is dark matter. Everything else, every star, planet, atom, and living thing, accounts for only a tiny fraction of what exists. This means the universe is governed almost entirely by things we cannot see or directly measure. Dark energy does not tear apart galaxies or atoms directly. At least not yet. Gravity still holds stars together. Electromagnetic forces still bind atoms. On small scales, the universe feels stable. But dark energy works patiently across vast distances where gravity is weak. It destroys proximity. It ensures separation. The practical consequence of this is isolation. Structures that are not gravitationally bound will drift apart forever. Entire regions of the universe are becoming unreachable, not because they disappear, but because the space between us expands faster than light can cross it. This creates a boundary called the cosmic event horizon. Anything beyond that horizon is permanently cut off. Its light will never reach us. Its future actions can never affect us. From our perspective, it might as well not exist. That horizon is not fixed. As expansion accelerates, it moves closer. Galaxies we can see today will one day cross it and vanish from view. Not in a dramatic explosion, not in a slow fade. They will simply stop being observable. This is not speculation. This is already happening. Right now, light emitted by some galaxies will never reach Earth. Those galaxies still exist, but the space between us expands too quickly. The photons are trapped, making progress locally but losing the race globally. From the perspective of an observer in the distant future, the universe will look profoundly different. Where we see thousands of galaxies, they will see only a few. Where we see a rich cosmic web, they will see isolation surrounded by darkness. Our own galactic neighborhood, known as the local group, contains roughly a few dozen galaxies bound together by gravity. The Milky Way, Andromeda, and several smaller companions form a stable island. Expansion cannot pull them apart. Gravity wins here, but beyond this island, the universe is slipping away. Larger structures, like superclusters, are already losing coherence. The farther apart their components are, the less gravity can resist expansion. Over time, these massive assemblies will unravel. Galaxies once connected by filaments will drift into solitude. This has profound implications for life and intelligence. The universe has existed for nearly 14 billion years. Stars began forming early in its history. Planets followed. Given the vast number of stars and the enormous age of the cosmos, it seems reasonable to expect intelligent life to have arisen many times. Some civilizations should be far older than ours. Some should be technologically advanced beyond comprehension. Yet we see nothing, no artificial structures reshaping galaxies, no unmistakable signals crossing interstellar space. No evidence of widespread colonization, silence. This contradiction is known as the Fermi paradox. If intelligent life is common, where is everyone? One explanation is that intelligent life is extraordinarily rare. Perhaps the conditions required for life are so specific that Earth is nearly unique. Maybe the emergence of intelligence is a cosmic fluke. Another possibility is more disturbing. Perhaps most civilizations do not survive long enough to spread. Somewhere between discovering technology and mastering the stars, something stops them, a barrier, a filter. This idea is known as the Great Filter. It suggests there is a step in the progression from simple life to interstellar civilization that is almost impossible to pass. The filter could lie behind us. Maybe the origin of life itself is so improbable that hardly anyone makes it that far. If so, humanity may already have passed the most dangerous stage, or the filter lies ahead. In that case, civilizations inevitably destroy themselves. Advanced technology brings immense power, nuclear weapons, artificial intelligence, engineered pathogens. Environmental collapse. Perhaps intelligence carries the seeds of its own extinction. If civilizations tend to annihilate themselves shortly after becoming capable of interstellar communication, the silence makes sense. We are listening to a graveyard, but there is another possibility, one tied directly to cosmic expansion. Even if civilizations arise and survive, the universe itself may prevent them from ever meeting. Expansion isolates regions of space faster than civilizations can spread. Even a species capable of traveling near the speed of light would be confined to its local gravitational island. Everything beyond would drift out of reach. This means the window for cosmic contact is limited. Early civilizations might have existed when the universe was denser and more connected. But as expansion accelerated, communication channels closed. Civilizations became trapped in isolation, unable to reach one another even if they survived. This isolation would deepen over time. Each cosmic island would be cut off permanently, its inhabitants unaware that others ever existed. From this perspective, the silence is not evidence of emptiness, it is evidence of separation. The universe may be full of life, but torn apart so efficiently that no one can ever confirm it. Dark energy ensures that this separation is final. Unlike ordinary motion, expansion cannot be reversed by effort or technology. You cannot build a faster engine to overcome it. Space itself stretches between destinations. Even light, the fastest thing in existence, cannot outrun expanding space beyond a certain distance. This means that the future of the universe is not just cold and dark, it is lonely. As time passes, fewer galaxies remain visible. Eventually, the only galaxies observable from Earth will be those bound to our local group. All others will have slipped beyond the horizon. For any future astronomers living then, the universe will appear small and static. They will have no evidence of expansion. No sign of the Big Bang, no cosmic microwave background. All the clues that reveal cosmic history today will have vanished. Ironically, they may conclude the universe is eternal and unchanging, not because it is, but because expansion erased the evidence. We live at a privileged moment. We can still see the universe as it truly is, vast, dynamic, and filled with structure. This window is closing, but expansion is not the only threat to structure. The universe also faces a future defined by entropy. Entropy measures disorder, it always increases, energy spreads out, differences disappear. Over time, everything moves toward equilibrium. Stars shine because energy is concentrated in their cores. That energy radiates outward, dispersing into space. Once dispersed, it cannot be recollected without additional energy. Each shining star is a one-way process, increasing the universe's entropy. Eventually, stars run out of fuel. Hydrogen is finite. As stars burn and die, the raw material for new stars diminishes. Star formation slows. This is already happening. The universe formed stars much faster in the past than it does today. In the distant future, star formation will cease entirely. No new lights will ignite. Existing stars will fade one by one. The universe will enter a long, dark era dominated by stellar remnants, white dwarfs cooling toward absolute zero, neutron stars slowly losing energy, black holes lingering as the last massive objects. Even black holes are not eternal. They evaporate through a slow process known as Hawking radiation. Over unimaginable spans of time, they lose mass and disappear. After that, the universe becomes a thin soup of particles and radiation stretched across ever-expanding space. Temperatures approach absolute zero. No energy gradients remain. Nothing meaningful can happen. This outcome is known as heat death. It is not violent. It is not sudden. It is a slow fading into stillness. But there may be even stranger endings. Some theories suggest the vacuum of space itself may be unstable. The universe could exist in a temporary state, a false vacuum destined to collapse into a lower energy configuration. If that happens, the laws of physics would change instantly within an expanding bubble moving at the speed of light. No warning, no escape, One moment the universe exists as we know it, the next it doesn't. Other models allow for a different catastrophe. If dark energy grows stronger over time instead of remaining constant, expansion could accelerate so violently that it tears apart galaxies, stars, planets, and eventually atoms themselves. This scenario is known as the Big Rip. In such a universe, destruction would not wait for trillions of years. It could arrive within tens of billions. Current observations suggest dark energy is constant, but our measurements are imperfect. The uncertainty leaves room for catastrophe. What makes all of this unsettling is how little we understand. Dark energy dominates the universe, yet we do not know what it is. Dark matter shapes galaxies, yet we cannot detect it directly. 95% of reality is invisible to us. We are navigating a universe built almost entirely from unknown substances and forces, watching as it slowly pulls itself apart. And this raises a final, deeply unsettling thought. Perhaps the universe is not empty because life is rare. Perhaps it appears empty because the universe is actively erasing connections. Perhaps intelligence arises, looks outward, sees nothing, and dies alone again and again, each time believing it is the only one. The void does not just consume matter, it consumes knowledge, history, and the possibility of contact. And it is spreading. The loneliness imposed by the universe is not emotional, it is physical, it is written into the geometry of space itself. Even if intelligence arises again and again across cosmic history, expansion ensures that most of it will never meet, never communicate, never know the others exist. Civilizations are not separated by hostility or distance alone. They are separated by accelerating space. To understand how final this separation is, you must understand the speed limit of the universe. Light travels at a constant speed. Nothing can move faster. This is not a technological problem. It is a structural rule of reality. No amount of engineering can change it. As space expands, it carries galaxies away from one another. When the expansion rate exceeds the speed of light across a given distance, communication becomes impossible. This does not violate physics because nothing is moving through space faster than light. Space itself is stretching. Imagine painting two dots on a rubber sheet and pulling the sheet apart. The dots separate faster and faster, even though neither dot moves on the sheet. That is what the universe is doing. At a certain distance, galaxies recede so fast that their light can never reach us. This distance defines the cosmic event horizon. Beyond it, reality exists, but is permanently inaccessible. Events there cannot affect us. From our perspective, those regions are erased. What makes this more disturbing is that the horizon is not fixed. It creeps inward as expansion accelerates. Galaxies that were once visible slip beyond it. Light that would have reached us if emitted earlier now never will. Right now, there are galaxies shining brightly whose photons are traveling toward Earth, but will never arrive. The space between us expands too quickly. Those photons are trapped in an endless journey, making progress locally but losing ground overall. This means that what we see in the night sky is not the universe as it is. It is the universe as it was. And even that view is shrinking. If you could freeze time and mark every galaxy that will ever be observable from Earth, you would find that most of the universe is already gone from our future view. The observable universe is not expanding anymore, it is contracting. This has consequences beyond astronomy. It shapes the fate of knowledge itself. Cosmology depends on evidence. The expansion of the universe, the Big Bang, dark energy, all of these conclusions rely on observing distant galaxies and ancient light. As the universe ages, that evidence disappears. In the far future, Observers living in our galaxy will not see the cosmic microwave background. It will have redshifted into wavelengths too long to detect. They will not see distant galaxies. They will see only their local gravitational island. From their perspective, the universe will appear static and small. They will have no observational proof that it ever expanded. They may conclude that their galaxy is the entire universe, and they would be wrong. This means that the universe does not merely erase structures. It erases truth. We are living in the only era when the universe can be understood empirically. Before now, it was too hot and uniform. After now, it will be too empty. We exist during a narrow window where evidence still exists. This makes the silence of the cosmos even more unsettling. If we are alone, then intelligence is rare beyond imagination. If we are not alone, then the universe itself is preventing contact. But isolation is only part of the story. The universe is not just expanding, it is cooling. As space expands, energy spreads out. Radiation stretches to longer wavelengths. Temperatures fall. This cooling is relentless and irreversible. The universe began in a hot, dense state. As it expanded, it cooled enough for particles to form, then atoms, then stars and galaxies. This cooling created complexity, but cooling does not stop. It continues until energy differences disappear entirely. Stars exist because they contain concentrated energy. Nuclear fusion releases that energy as light and heat. That energy radiates outward, dispersing into space. Once dispersed, it cannot be reclaimed. Every star that shines is running down a cosmic battery. Hydrogen fuel is finite. Each generation of stars locks some of it away in remnants that cannot fuse. Over time, less fuel remains for new stars. Star formation slows. Observations show that the universe formed stars much more rapidly billions of years ago. Today, star formation has dropped dramatically. Galaxies are running out of cold gas. In the distant future, no new stars will form anywhere. The last stellar nurseries will fall silent. This marks the beginning of a long, dark era. At first, the universe will still glow faintly with existing stars. Red dwarfs, the smallest and longest-lived stars, will dominate. Some will burn for trillions of years. But even they will eventually exhaust their fuel. When the last star fades, the universe will lose its primary source of light. After that, only remnants remain. White dwarfs, the cores of dead stars, will slowly cool toward absolute zero. Neutron stars will spin down and fade. Brown dwarfs will drift invisibly through space. Black holes will remain as the most massive objects, but even they are not eternal. Quantum effects cause black holes to emit radiation. This process is unimaginably slow, but given enough time, every black hole evaporates. The largest black holes will take longer than the current age of the universe, multiplied by itself many times over. But they too will vanish. When the last black hole disappears, the universe enters a new phase. There are no stars, no planets, no massive structures, only isolated particles and radiation drifting through expanding space. Temperatures approach absolute zero. Energy gradients vanish. Nothing can happen. This is heat death. Heat death is not destruction in the violent sense. It is the end of change. The universe reaches maximum entropy, a state of complete equilibrium. Entropy measures how evenly energy is distributed. When energy is uneven, work can be done. When it is perfectly even, nothing changes. The second law of thermodynamics states that entropy always increases. The universe obeys this law without exception. Stars, galaxies, black holes, all of them increase entropy. They speed up the universe's journey toward equilibrium. Once equilibrium is reached, time loses meaning. Without processes to mark its passage, the universe becomes static in every meaningful sense. But heat death may not be the only ending. There are scenarios far stranger and more abrupt. One possibility is that the vacuum of space is unstable. According to quantum field theory, the universe may exist in a false vacuum, a temporary energy state. If the vacuum decays into a lower energy state, the laws of physics change instantly within an expanding bubble. This bubble expands at the speed of light. Everything it touches is destroyed, not violently, but fundamentally rewritten. Atoms may not exist in the new vacuum. Forces may behave differently. Chemistry may be impossible. There would be no warning. The bubble would arrive without notice. No technology could prevent it. No escape would be possible. Another scenario involves dark energy itself. If dark energy grows stronger over time rather than remaining constant, expansion accelerates catastrophically. In such a universe, expansion does not merely isolate galaxies. It tears them apart. First, galaxy clusters dissolve. Then galaxies themselves unravel. Stars are pulled from their orbits. Solar systems disintegrate. As expansion accelerates further, even planets are torn apart. Finally, atomic bonds fail, matter itself is shredded. This is known as the Big Rip. Current observations suggest this outcome is unlikely. Dark energy appears consistent with a constant value, but our measurements are limited. A small deviation could change the future dramatically. What makes all of this unsettling is not just the scale, it is our ignorance. Dark energy dominates the universe, yet we do not know what it is. Dark matter shapes galaxies, yet we cannot detect it directly. Ordinary matter, the only thing we understand well, makes up a tiny fraction of reality. 95% of the universe is invisible and mysterious. We are passengers in a cosmos governed by forces we barely comprehend, watching as it drifts toward emptiness. And there is another uncomfortable truth. The universe may not be hostile to life intentionally, but it is indifferent. It allows complexity briefly, then removes the conditions that make complexity possible. Life exists only during a narrow window of cosmic history. Before that window, the universe was too hot. After it, the universe is too cold and empty. We exist during that window. This makes consciousness extraordinarily fragile, a brief spark in a vast timeline of darkness. Perhaps intelligence arises many times, in many places, only to be erased by expansion and entropy. Each time believing it is alone. Perhaps the universe is full of silent observers, each trapped on their own shrinking island, watching the stars fade, unable to know that others are doing the same. The void does not just separate matter, it separates minds, and as the universe continues to expand, that separation becomes absolute. Despite how bleak this future sounds, the universe did not always look this way, and it will not always move at the same pace. Its story is one of dramatic shifts, sudden transitions, and fragile balances that allowed complexity to emerge at all. To understand why existence is so temporary, we must look backward to a time when emptiness had not yet taken control. The early universe was the opposite of what we see today. Space was smaller, matter was denser, energy was concentrated. Galaxies were closer together, interacting and colliding frequently. Star formation was intense. The cosmos was alive with activity. In those early epochs, gravity ruled. Dark energy existed, but its influence was negligible because space itself was limited. Gravity pulled matter into dense regions, forming stars and galaxies rapidly. The cosmic web was tighter, brighter, more connected. This was the era when complexity flourished. Galaxies merged and evolved. Heavy elements formed inside stars and were scattered by supernova. Planets assembled from enriched material. Chemistry became rich enough to allow life. Everything that makes life possible depends on this era of density. Without gravity's early dominance, stars would never have formed. Without stars, there would be no elements beyond hydrogen and helium. No carbon, no oxygen, no chemistry capable of supporting life. But this golden age was always temporary. As the universe expanded, matter thinned, gravity weakened across large distances. Dark energy, constant per unit of space, grew in influence. At a certain point, it overtook gravity on cosmic scales. That transition changed everything. Galaxies stopped forming as rapidly. Large-scale structure froze in place. The cosmic web stopped growing. The universe entered a phase of gradual decline. This shift occurred billions of years ago. We are already living in a universe past its peak of creativity. Most of the stars that will ever exist have already been born. Most of the planets that will ever form already exist. The future holds fewer opportunities for new beginnings. This realization reframes humanity's place in time. We tend to imagine ourselves as latecomers, arriving near the end of cosmic history. In reality, we are early. If the universe lasts for trillions or even quadrillions of years, then intelligent life arose astonishingly soon after conditions allowed it. We exist near the dawn of awareness, not its end. This suggests something important. Either intelligence is easy to produce once conditions are right, or we are an extraordinary exception. If intelligence is common, then the early universe may have been filled with emerging civilizations. But expansion and isolation would have cut them off quickly. Many may have arisen, flourished briefly, and vanished without ever knowing others existed. If intelligence is rare, then the fact that we exist at all becomes even more significant. It would mean the universe produced consciousness only a handful of times before conditions deteriorated. Either way, the universe is not designed for permanence. Even the most stable structures we know are temporary. Galaxies slowly lose stars, stellar orbits decay, interactions redistribute energy until systems relax into simpler states. Over immense timescales, even gravitationally bound systems evolve toward equilibrium. Nothing lasts forever. This impermanence applies not just to physical structures, but to information itself. Information requires order. It requires energy differences, stable patterns, and mechanisms to preserve them. As entropy increases, maintaining information becomes harder. Memories fade, records decay, signals dissipate. In the far future, even if intelligent beings persist in some form, preserving knowledge will become increasingly difficult. Without stars, energy sources vanish. Without energy, computation becomes impossible. Consciousness depends on complexity. Complexity depends on energy flow. Energy flow depends on gradients that the universe is steadily erasing. This raises a profound question. Is the universe fundamentally hostile to meaning? Meaning, in any operational sense, requires persistence. It requires continuity. It requires the ability to connect past, present, and future. A universe that destroys connections and erases structure undermines meaning at its foundation. Yet meaning exists now. We think, we remember, we imagine futures, we ask questions about the universe that created us. This suggests that meaning is not guaranteed, but emergent and temporary, like everything else. Perhaps that is why it feels so intense. Life is not sustained by permanence, it is sustained by urgency. Stars do not shine forever, but while they shine, they create the conditions for life. Civilizations do not last forever, but while they exist, they generate culture, knowledge, and purpose. The universe may not care, but existence allows caring to arise. This perspective changes how we view cosmic isolation. Isolation does not necessarily mean insignificance. It may mean rarity, and rarity can amplify value. If each conscious civilization is confined to its own shrinking island, then each one carries the full burden of awareness for that region of space. Each one becomes the universe observing itself locally. From that view, intelligence is not meant to spread endlessly. It is meant to emerge briefly, reflect, and vanish. But there is another possibility, one that challenges the finality of isolation. Some scientists speculate that intelligence itself could alter its cosmic fate, not by stopping expansion, but by adapting to it. Advanced civilizations might migrate inward, concentrating around long lived energy sources. They might restructure matter to maximize efficiency. They might compress computation into minimal energy states. In principle, consciousness could persist far longer than stars by exploiting physical loopholes. There are theoretical models suggesting that information processing could continue indefinitely in an expanding universe, though at an ever slowing pace. Subjective time could stretch infinitely, even as physical time advances. In such scenarios, intelligence does not defeat entropy. It rides it, but these ideas remain speculative. They depend on unknown physics, perfect engineering, and assumptions that may not hold. And even if they work, they apply only to civilizations that survive long enough to attempt them, which brings us back to the most immediate uncertainty. Before cosmic isolation and heat death become relevant, civilizations must overcome their own fragility. Technology gives power faster than wisdom. The ability to alter environments, genomes, and machines arrives before the ability to manage consequences reliably. This creates a narrow window where self-destruction becomes likely. The universe does not need to kill civilizations directly. It only needs to allow them to destroy themselves. From this perspective, cosmic emptiness may not be caused by expansion alone. It may be compounded by repeated failures of intelligence. Civilizations may rise, glimpse the universe, and collapse before leaving lasting traces. If that is the case, then the silence is not only cosmic, it is historical. We may be listening not to an empty universe, but to one that has already spoken and fallen silent. And this places humanity in a dangerous position. We are powerful enough to affect our planet, our biosphere, and potentially ourselves on a global scale. We are not yet wise enough to be confident in our restraint. If there is a great filter ahead of us, it may not be cosmic. It may be internal. The universe does not promise survival. It offers opportunity, briefly. What we do with that opportunity matters. Because while expansion will one day isolate and erase, the near future is shaped by choices about cooperation or conflict, preservation or exploitation, curiosity or denial. The universe may be indifferent, but we are not required to be. And that distinction may be the most important one of all. The fact that the universe allows awareness to arise at all suggests something remarkable. Out of particles and forces, out of expansion and entropy, minds appear, they observe, they question. They assign meaning where none is guaranteed. This alone makes intelligence one of the rarest phenomena in existence. Yet intelligence did not appear because the universe intended it. It emerged as a side effect of complexity. Given enough matter, enough time, and the right conditions, systems become self-organizing. Chemistry becomes biology. Biology becomes cognition. Cognition becomes reflection. But reflection does not ensure survival. The universe is not designed to protect thinking beings. It provides a brief window of stability, then withdraws it. Life must act quickly, adapt relentlessly, or vanish. This places civilizations in a race against multiple clocks. One clock is internal, technological growth accelerates rapidly, often outpacing ethical and social maturity. The same tools that cure disease can destroy ecosystems. The same networks that connect minds can destabilize societies. Another clock is environmental. Planets change, stars evolve, habitable zones shift, resources deplete. A third clock is cosmic. Expansion isolates, energy disperses, opportunities shrink. These clocks do not tick at the same rate, but they all move in one direction. Humanity currently stands at a critical intersection. Our technology gives us unprecedented power, yet our understanding of long-term consequences remains limited. We can alter climate systems, manipulate genomes, and build machines capable of independent decision making. At the same time, we remain bound to a single planet, dependent on a fragile biosphere shaped by billions of years of evolution. If we fail to manage this imbalance, cosmic questions become irrelevant. Our story ends locally. If we succeed, something extraordinary becomes possible. Survival allows continuity. Continuity allows accumulation of knowledge. Accumulated knowledge enables foresight. A civilization that survives its early technological phase gains the ability to think on cosmic timescales. It can plan not just for centuries, but for millennia and beyond. Such a civilization might attempt to preserve life and information far longer than nature would otherwise allow. Not by resisting the universe, but by understanding it. Understanding expansion means accepting isolation. There will be no galactic empire spanning the universe. There will be no ultimate union of intelligence across cosmic space. But within gravitationally bound regions, vast projects remain possible. The local group of galaxies will remain intact for trillions of years. The Milky Way and Andromeda will eventually merge, forming a single massive galaxy. Within that structure, stars will continue to shine for immense spans of time. This creates a long-term refuge. Advanced civilizations could spread throughout this region, harvesting energy from stars, reorganizing matter, and preserving habitats. Even as the rest of the universe slips beyond reach, this island remains accessible, but even this refuge is temporary. Star formation will eventually cease, existing stars will die, energy will become scarce. To survive longer, intelligence must adapt again. Some theories propose using black holes as energy sources. Rotating black holes contain enormous amounts of extractable energy. With sufficiently advanced technology, it may be possible to tap that energy through mechanisms like the Penrose process. Others suggest converting matter into energy with near perfect efficiency, minimizing waste. There are even ideas about restructuring computation itself, slowing processing to match decreasing energy availability, allowing subjective experience to stretch indefinitely. These concepts push physics to its limits. They assume near perfect control over matter and energy. They assume stability over timescales far beyond anything humanity has experienced, and they still do not defeat entropy. They merely delay its consequences, but delay matters. Delay creates time for experience, reflection, and choice. If intelligence can persist for trillions of years instead of millions, the amount of meaning generated increases dramatically. This reframes survival not as defiance, but as stewardship, stewardship of energy, stewardship of information, stewardship of consciousness itself. Yet all of this remains hypothetical. Before reaching such heights, civilizations must survive their most vulnerable phase. History offers little reassurance. Human societies struggle with coordination even on small scales. Conflicts arise over resources, beliefs, and power. Technology amplifies both cooperation and destruction. There is no guarantee that wisdom scales with capability. This may explain the cosmic silence better than expansion or rarity. Perhaps many civilizations reach a point where they can destroy themselves faster than they can unite. Perhaps most fail. If that is true, then the universe is not empty because life is rare. It is empty because survival is hard. This interpretation carries a heavy implication. The absence of evidence is not evidence of absence. It may be evidence of repeated collapse. If intelligence tends to self destruct, then each surviving civilization becomes exceptionally valuable. Each one represents a rare victory over a universal failure mode. From that perspective, the future of intelligence matters beyond any single species. The universe may produce minds only to lose them, but if even one lineage learns to persist, it changes the narrative. Humanity may be at the beginning of that test. Our decisions in the coming centuries will determine whether we become another brief flicker or something long or lasting. The universe will not intervene. There will be no cosmic rescue. We must choose cooperation over short-term advantage, sustainability over exploitation, knowledge over denial. These are not moral platitudes. They are survival strategies in a universe that offers no second chances. If we fail, the universe will continue without noticing. Stars will still burn. Galaxies will still drift apart. Expansion will still erase connections. If we succeed, something unique happens. The universe gains a witness that endures. A mind that persists long enough to understand not just its surroundings, but its place in cosmic history. That alone would make survival meaningful, even if nothing else lasts, because meaning does not require permanence. It requires awareness, and awareness, however brief, is the rarest outcome of all. Awareness does more than observe the universe. It transforms how the universe is experienced. Without consciousness, expansion, entropy, and time unfold without interpretation. With consciousness, they become questions, fears, hopes, and choices. In this sense, intelligence is not just another phenomenon within the cosmos. It is the lens through which the cosmos becomes meaningful. This makes the disappearance of intelligence more tragic than the fading of stars. When a star dies, energy is redistributed. When a mind disappears, a perspective is lost forever, and perspectives do not repeat. Even if life arises elsewhere, it will never replicate the exact experiences, thoughts, and interpretations of another civilization. Each one represents a unique way for the universe to understand itself. From this viewpoint, cosmic isolation is not merely about distance. It is about the permanent loss of unshared perspectives. Expansion ensures that most perspectives will never meet. Yet this does not diminish their value, it magnifies it. A thought that exists only once is not meaningless. It is precious precisely because it is rare, but rarity does not guarantee longevity. The universe sets strict constraints on how long complexity can survive. Energy availability declines, temperature differences vanish, order dissolves into equilibrium. No amount of intelligence can fully escape these constraints. The laws of thermodynamics apply universally, but intelligence can influence the path taken within those laws. There is a difference between passive decay and managed decline. A civilization that understands its limits can choose how to use its remaining time. It can prioritize preservation over expansion, depth over breadth, understanding over dominance. This idea challenges the traditional image of progress as endless growth. In a finite universe, growth must eventually stop. The future of intelligence may not be about conquering space, but about mastering restraint. Instead of spreading across galaxies, advanced civilizations might focus inward, optimizing their local environment, reducing waste, and preserving stability. Instead of exponential expansion, they may pursue equilibrium. This would represent a fundamental shift in values. Power would no longer be measured by territory or energy consumption, but by efficiency, resilience, and continuity. Such a civilization would look alien to us, not because of its technology, but because of its priorities. It would understand that the universe does not reward excess, it rewards balance. But achieving this balance is extraordinarily difficult during early technological phases, when power grows faster than wisdom. This again raises the question of filters. If the great filter lies ahead, it may not be a single catastrophic event. It may be a long series of temptations, short-term gains that undermine long-term survival, environmental collapse, uncontrolled artificial intelligence, weaponized biology, social fragmentation amplified by technology. None of these require malice. They require only misalignment between capability and responsibility. The universe does not punish such misalignment deliberately, it simply allows consequences to unfold. In this sense, the universe is a neutral stage, not a hostile actor. It offers opportunities without guidance. Whether those opportunities lead to flourishing or collapse depends entirely on the choices made by intelligent beings. This makes ethics a survival mechanism, not a luxury. Systems that encourage cooperation, foresight, and restraint are not merely moral preferences. They are adaptive strategies in a universe that offers no forgiveness. The silence of the cosmos may therefore be instructive. It may be telling us that intelligence must mature quickly or vanish. If civilizations typically fail, then survival itself becomes evidence of exceptional adaptation. Humanity has not yet demonstrated that adaptation. We have created technologies capable of global impact, but our decision-making systems remain fragmented and reactive. We are still learning how to coordinate at planetary scale. This is the true challenge of intelligence, not inventing tools, but aligning minds. The universe does not care if we succeed, but if we do, something extraordinary happens. We become not just inhabitants of the universe, but participants in its story. A civilization that survives long enough to understand cosmic expansion, entropy, and its own fragility gains a rare perspective. It sees that existence is temporary, but awareness is real. It sees that permanence is impossible, but meaning is not. Meaning arises from engagement, not duration. This reframes the future. The goal is not to escape death, whether personal or cosmic. The goal is to act wisely within inevitability. A civilization that accepts this may choose to preserve knowledge even as structures decay. It may archive its understanding in forms resilient to time. It may attempt to send messages outward, not expecting reply, but as an expression of existence. These messages may never be received. Expansion may erase them, but their creation still matters. They represent the universe attempting to speak through one of its brief moments of awareness. And even if no one listens, the act itself has value. This perspective dissolves the fear of isolation. Isolation does not negate significance. It defines the context in which significance arises. If we are alone, then our actions matter more, not less. If others exist but are unreachable, then each civilization carries its own meaning independently. The universe becomes not a single narrative, but countless parallel stories, each unfolding on its own island of spacetime. None of them dominate, none of them last forever, all of them matter while they exist. This view does not require optimism. It requires clarity, clarity about limits, clarity about fragility, clarity about responsibility. The universe does not promise survival. It offers possibility. Possibility exists now. What we choose to do with it will define whether intelligence remains a brief anomaly or becomes a sustained presence, however temporary, within cosmic history. The void will continue to expand, entropy will continue to increase, stars will continue to fade, but for now, awareness exists. And that is enough to make this moment extraordinary. If awareness is temporary, then the present moment carries an unusual weight. It is not just another point in time, it is a narrow opening in which the universe briefly becomes conscious of itself. Before this moment, the universe was silent. After it, silence will return. What exists now is a fragile interruption. This changes how progress should be understood. Progress is often imagined as accumulation, more technology, more reach, more control. But in a universe governed by expansion and entropy, accumulation cannot continue indefinitely. Eventually, growth collapses under its own complexity or runs out of energy. A deeper form of progress may be refinement rather than expansion. Refinement means reducing waste, increasing coherence, and aligning action with long-term survival. It means learning how to exist without exhausting the conditions that make existence possible. This applies not only to civilizations, but to individuals. Each conscious life is itself a brief interruption. Thoughts arise, memories form, intentions guide action, and then the process ends. No mind escapes impermanence, yet meaning is not diminished by this, it is sharpened. A short poem is not less meaningful than a long one. A fleeting experience is not less real than a permanent structure. The universe may erase everything eventually, but it does not erase what has been experienced. Experience is not undone by its disappearance. This reframes the fear of cosmic oblivion. Oblivion does not negate existence retroactively. The fact that something ends does not mean it never mattered. Stars that have burned out still shaped galaxies. Civilizations that collapsed still altered history. Lives that ended still influenced others. Causation does not vanish when structures fade. In this sense, the universe carries traces even as it forgets. Even if all matter decays and all energy spreads evenly, the fact that complexity once existed remains true. Nothing can undo that truth. This perspective allows for responsibility without despair. We are not tasked with saving the universe. We are tasked with acting wisely within it. We cannot stop expansion. We cannot defeat entropy, but we can choose how we respond to them. We can choose whether intelligence amplifies suffering or reduces it. We can choose whether technology deepens division or enables cooperation. We can choose whether awareness becomes a force for understanding or for destruction. These choices do not require cosmic permanence to be meaningful. They matter because they affect real experiences now and in the near future. The universe is not a judge. It does not reward virtue or punish failure. It only permits outcomes. This neutrality places the burden of value creation entirely on conscious beings. Value is not embedded in the cosmos. It is generated locally by minds. This makes intelligence the rarest and most consequential phenomenon we know. Even if intelligence is common in absolute terms, it is sparse relative to the scale of the universe. It occupies tiny islands of space and time. Most of reality is empty and unconscious. When consciousness appears, it transforms a small region of the universe into something that can care. That alone justifies effort, but effort without direction can be destructive. History shows that intelligence does not automatically produce wisdom. It often produces power first. Power amplifies intent, but it does not improve it. If the future of intelligence depends on alignment between capability and responsibility, then the central challenge is not technological. It is cultural. Cultures shape incentives. Incentives shape behavior. Behavior shapes outcomes. A civilization that rewards short-term gain at the expense of long-term stability will collapse regardless of its technology. A civilization that values foresight, cooperation, and restraint has a chance to persist longer. This is not speculation. It is visible in ecological systems, economic systems, and historical societies. The universe simply scales these dynamics up. At cosmic scale, the same principles apply. Systems that exhaust their energy sources and destabilize their environments fail. Systems that maintain balance persist. Balance does not mean stagnation, it means dynamic stability. Life itself is a balancing act, constantly countering entropy through energy use. When that balance fails, life ends. Civilizations are extensions of this process. They must balance growth with sustainability, innovation with caution, ambition with humility. The universe offers no external correction. Mistakes are final. This makes foresight a survival trait. It also makes humility essential. The universe is vast, ancient, and largely indifferent. Any civilization that mistakes temporary dominance for cosmic significance risks self-destruction. Understanding our smallness is not a source of despair. It is a source of perspective. Perspective allows prioritization. It allows us to see that endless accumulation is unnecessary, that meaning does not require conquest, and that cooperation is not weakness. In a universe that isolates and erases, connection within our reach becomes precious. The people we can influence, protect, and support matter more than hypothetical futures beyond our control. This does not diminish the importance of long-term thinking. It grounds it. Long-term survival begins with near-term responsibility. If humanity survives its current phase, it may one day look back on this era as the most dangerous. Not because of external threats, but because of internal ones. The capacity to destroy ourselves arrived before the capacity to govern ourselves wisely. Whether we bridge that gap remains uncertain, but uncertainty does not imply futility, it implies choice. The universe does not determine outcomes in advance. It sets constraints, not destinies. Within those constraints, intelligence still matters. We still matter. Even if the universe ends in darkness, the light that existed was real. Even if isolation is inevitable, connection now is meaningful. Even if awareness fades, the fact that it arose at all is extraordinary. The void may be expanding, but it has not erased this moment. And what we do in this moment shapes the only part of the universe we can ever affect. At the end of all these considerations, one truth remains unavoidable. The universe does not offer guarantees. Not for stars, not for galaxies, not for civilizations, and not for consciousness itself. Everything that exists does so under temporary conditions, balanced delicately between forces that allow structure and forces that erase it. This does not make existence meaningless, it makes it conditional, and conditional things demand attention. The mistake is assuming that meaning must be permanent to be real. Permanence is rare in the universe. Even atoms decay under the right conditions. Even space itself changes. If meaning required eternity, nothing would ever qualify. Meaning exists because something is experienced, not because it lasts forever. The universe does not remember, but minds do. And while minds exist, memory exists, intention exists, choice exists. That is enough. The expansion of the universe will continue. Galaxies will slip beyond reach. Energy will thin out, darkness will grow, These processes are not threats in the usual sense. They are background conditions as fundamental as gravity or time. What matters is how intelligence responds while it can still respond. The future is not a single outcome waiting to happen. It is a range of possibilities constrained by physics and shaped by decisions. Humanity stands within that range now. We cannot change the large scale fate of the cosmos, but we can determine whether intelligence survives long enough to understand it, reflect on it, and act with awareness rather than impulse. If intelligence disappears quickly, the universe will return to silence, having barely noticed. If intelligence endures, even briefly on cosmic scales, something unprecedented occurs. The universe becomes self-aware for longer than an instant. That awareness does not need to conquer galaxies or defeat entropy. It only needs to exist with clarity, clarity about limits, clarity about consequences, clarity about responsibility. The tragedy would not be that everything ends. The tragedy would be ending without understanding what existed. We are capable of understanding now. We know the universe is expanding. We know it will grow colder and emptier. We know our existence occupies a narrow window between extremes. We know intelligence is fragile. This knowledge is not a curse. It is a guide. It tells us that short-term thinking is dangerous, that cooperation is not optional, that restraint is not weakness, that care is not naive. These are not moral preferences imposed from outside. They are strategies that emerge naturally in a universe with finite opportunity. If intelligence has any role to play, it is this: to recognize reality as it is and act wisely within it. The universe does not ask for worship, it does not demand despair, it does not reward hope, it simply allows. Within that allowance, intelligence becomes the only source of value. Value is created when suffering is reduced, when understanding increases, when futures are preserved long enough to be experienced. Even small acts matter in this framework, even local improvements matter, even temporary kindness matters. Because they shape real experiences in a universe that offers no redo. The fear that nothing lasts should not paralyze action. It should sharpen it. A song is not less beautiful because it ends. A life is not less meaningful because it is finite. A civilization is not less significant because it does not last forever. What matters is what happens while it exists. The universe is vast and indifferent, but it has produced at least one place where meaning can arise. Here, now, that alone is extraordinary. Whether humanity becomes a brief spark or a sustained flame remains uncertain. But uncertainty does not erase responsibility. It creates it. We cannot know how far intelligence can go, but we can choose not to extinguish it prematurely. We can choose to understand instead of deny, to cooperate instead of dominate, to preserve instead of exhaust. These choices will not change the ultimate fate of the universe, but they will change the lived reality of every conscious being affected by them. And lived reality is the only place where meaning exists. One day, far in the future, the last structures will fade. The last energy gradients will flatten. The universe will fall silent again. But before that happens, something remarkable occurred. The universe looked at itself and asked questions. That fact cannot be undone. No matter how dark the future becomes, there was a moment when the cosmos was aware. And that makes this moment worth everything.